the symbol for this is torque. So not T, tau. Tau is equal to, this should be R bar cross F bar. So let's take the, so there's a particle, torque about this point will define it, about origin will define it. So let this be coordinate system, and let this be R bar. I'll apply a force. So where the particle lies in XY plane, the particle lies in XY plane, and let the position, let me call this is theta. Then according to definition, the torque is given as R bar cross F bar, that one. So if you further extend this line, so you have to curl fingers from R bar towards F bar, no? So therefore this will become theta. So how it should be? R cross F. So what is the direction of torque? What is the, how the force is acting along x-axis? What about R bar? R bar we can define position vector as R bar equal to R sine theta I cap R cos theta j cap. Let me go for it. R bar cross F bar. This will be R sine theta I cap.
The R bar is R cos theta I cap and R sin theta j cap.
Okay, this symbol. Okay, Matt, thank you. This is R cos theta I cap. This is R sine theta j cap. That one. Cross. So what is this? Force is acting along x-axis. F I cap. So let's do one thing. I cross I will be 0. J cross I cross JK, J cross I will be minus K. So this I'm getting R sine theta F minus K cap. So minus K cap. How the torque will be directed along negative K cap it is. K cap means how we have to show it. Minus K cap. The torque will be directed along negative y-axis here. This is the XY plane. No? I'll take one more. The direction of torque will be this R bar. This is a torque. Or we just show rotating effect like this. How is the torque? Torque will act along negative z-axis. Positive z-axis will be out of the plane. So it's a rough diagram. I'm showing it here. So now what this will do, it will produce a rotational effect. This torque, what it will do, it will produce, I'm discussing torque of a particle, that one. Torque on a particle about origin. So we do find out using this particular formula. Now, let me apply the force in different way. This is about basic idea of the torque. So what torque will do, it will produce rotational effect here. So where is the rotational effect? I'm not seeing. So let's do one thing. I'll take example of rigid body itself. So this is a rod. It is hinged about this one. I'll apply a force perpendicular to the rod. Then definitely it will have a rotational effect. So don't bother mg. Don't bother mg. If I say that g, then you have to take that one. So then the rod starts rotating. No, it's hinged about one end. At the other end, I'll apply force. Then this particular is called as a OA. Then what is the torque acting? Torque equal to R bar cross F bar. What is R bar? OA bar cross F bar. Let me define coordinate system XY axis here. This should be equal to length, let OA equal to L. Then this will be Li cap cross. This should be minus F J cap. I cross J key. So this will be minus LF K cap here. No, what is the direction of torque? The torque will be directed into the plane. We show sense of rotation. So what happened to the rod? The rod will try to rotate here. How the torque will act along the about an axis passing through perpendicular to plane of the rod. Like similarly omega, no, how we used to show. So it's a practice of showing torque like this. Torque will not be like this. How the torque will be into the plane. OA bar cross A bar. Curl your fingers. You have to take right hand. Curl it. I think I had to. It should be like this, no? You have to curl it from OA bar towards A bar. You have to curl it. Then the thumb will give the direction of torque. Take help of cross product. Vector cross product will be easy for you. Or I'm showing the K cap here. Along minus K cap, the thumb will point and you have to curl from R bar, from OA bar towards A bar. Means you have to curl it here. You should curl it at this particular point. So the axis will pass through point A or point O. No, it will pass through point O because this is a fixed axis of rotation. No? It will rotate about this particular point. Able to manage? So this is about the torque, that one. And now what happens, sir, if I apply at an angle? Let's see the same example. And rather than mathematics, no, directly I'm coming to the one example itself. So I'll apply force at an angle theta. How to define this? And there's a coordinate axis system. I'm taking xy like this. The length of the rod is L. Okay, let's define again from the definition. This is OA bar cross F bar. What is OA bar? Li cap cross. This will be F sine theta I cap minus F cos theta j cap. See the unit vectors, they are going to help us. I cross I will be 0. I cross I will be 0. So then I cross j will be k. So this will be minus LF cos theta k cap. This is the magnitude of torque. And what was the direction? Again, in what sense the rod will rotate here. So how the torque will act? Along z axis into the plane of the paper. The torque is an axial vector. It will act through point O. Or we could have done this in very simple way, no? What is a very simple way? Shall we resolve this F cos theta or the force F cos theta, F sin theta? Which particular component of force will set up a torque here? I'm going to introduce one very good condition here. There's a rod. Instead of using this formula, let me resolve this. This is F perpendicular force. And what about this? This force is parallel to the rod. Which component of force will set up a torque? Let me do one thing. Torque is equal to OA bar cross F perpendicular. Then what about due to this? OA bar cross F parallel. So from where you are bringing it? This F bar, can I split it up like F sin theta minus F cos theta? What is F sin theta? Is nothing but F perpendicular, and F cos is F parallel. So what is the angle between F perpendicular? OA is L, F perpendicular sin 90. This is L, F parallel sin 0. Because what is the angle between R bar and F? Will be 0, no? So what is the basic formula? R F sin theta. What is theta? Angle between R bar and F bar, no? Angle between R bar and F bar. What is the angle between R bar and F bar? That is theta. So now apply that here. So what is the angle between OA bar and F bar? 90 degrees. What is the angle between OA bar and F parallel? Will be 0. So I am getting finally LF perpendicular. What is F perpendicular? Should be F cos theta. Only magnitude and I'm showing the sense here. So what is the sense? Clockwise. So curl fingers in the direction of arrow, the thumb will point into the plane of paper. Are you getting? Curl fingers in the clockwise sense. Curl it. So sir, how to curl? You're saying curl it, how to curl? So it'll be like this. Huh? Look at the thumb. Thumb will point into the plane of paper. Don't do like this. Huh? In the sense of arrow, you have to curl it. The thumb will point. The thumb will be pointing in the direction of the torque here. So where the torque will act along the axis passing through point 2. So now one very important thing you'll notice. What is that? If a force intersect axis of rotation. So what is the axis of rotation? Z axis here. Passing through point 2, Z axis. I'll write it here. What is the axis here? Axis is about this axis, torque is set up about that axis. So now F parallel, what is doing? It will intersect axis of rotation. So therefore, if a force intersects axis of rotation, will it set up a torque? The answer is no. Answer is 0. Yes, it will not set up a torque. So shall I put now condition? If a force, the first condition, if a force intersects axis of rotation, the torque setup by such a force will be 0. There's a one practically I brought it here. And then also one more very important thing you noticed. This is like a two forces, no? F perpendicular, F parallel. Means at a point, if two forces are acting, can we write like this? Shall I take example of this one? So one more, the same. So one force